Data Communication and Network, Lecture 1. The introductory section of this course is going to be based on computer communication and network first. And then as we go along, we'll embrace how data factors interact. Okay? So it's basically the same title, but more from the computer point of view. Yeah. Since computer systems are practically what makes communication possible these days. So lecture 1, we'll delve into some of the introductory levels within this course. Okay. To start out with, the aim of this course is to introduce you to the world of computer networks, basically. So at least you could know the science being used in running some of these computer networks, and also gain some knowledge in the various professional fields that are involved. There are going to be a whole bunch, or there are actually a number of professional fields that goes with this course. The most common ones are system administration and network administration. But generally, most of the IT courses or IT programs have data communication or computer communication networks as the fundamentals. They build most of the system on that. Without data communication, it would be in a way you wouldn't really have other professional fields to ride on, basically. So I guess what I'm trying to say is, if you really want to pursue any professional fields within IT, data communication forms the bedrock of it. If you're going to be a programmer, you're going to be a system engineer, system analyst, system developer, system administrator, network administrator, or what have you. Practically, systems in general need some ways of handling information transmission or communication from one node to another, or from one device to another. And there are a number of fields that are involved, and they all have this as their bedrock. So it's a really good first, level to start off your IT course. We good? So I guess the question here is, in much more practical sense, what exactly is computer networks? Maybe that's a question we should be asking, since we want to know the science involved and also pick up some fields that goes with it, so at least we can situate ourselves very carefully or strategically when it comes to whatever we want to pursue in IT in general. What do we really mean by computer network? And that should be one of the key things you should be looking at within this course. Computer networks generally talks about computer designs. It design, the structuring of it, the setup of it is what I want to talk about in terms of what a computer network is. Okay. So generally, a computer network will be a set of serial lines that attaches terminals to other systems. It could be mainframes, servers, uh, switches, routers, access points, whatever. Basically, that though the key thing is the serial lines that makes uh, communication possible, or that makes it possible to form that network. It could be physical or indirect, or it could be direct, where you use a physical medium actually to make the computer network possible. So if whenever we talk about computer network, we're talking about how set of serial lines are used to interconnect various terminals to other systems. Okay, so the framework here could be, so a mainframe could be a server, a switch, a router, access point, or whatever. Okay? And usually, telephone networks are the, let me put it this way, telephone networks started pretty much most of how communication networks were built, or when it first started, it started out with telephone networks. They form the basis on which most of today's networks are built on, or are built today. And usually, the telephone networks handles your voice transmission. Um, if I'm not mistaken, the British were huge pioneers when it comes to using a set of serial lines to create various network to develop voice transmission over their telephone network. Hence, the British Telecom have been the one of the key telecommunication companies in the world that have been around for quite a long time. They mostly started with voice, and then a few obviously other countries picked up on it to build up their own kinds of networks that handles other services besides just voice. But telephone networks form the basis on which most computer networks are started in a way. So usually when we talk about telephone networks, we mean voice traffic. It's usually used for carrying voice traffic, but today they do go beyond voice traffic. Telephone networks today they do have data as well, including videos. Uh, it just tells you how far some of these serial lines of connectivity have come over the years, mostly to address some of the uh, key drives within data communication, which we talked about earlier, uh, from enterprise resource needs, uh, uh, technological trends, uh, systems advancements over the years. Yes, some of these key things have basically improved even the key networks that started it all. Another network that handles was purely handling a specific type of message over the years was cable network, which usually handles video signals. Today, like I said, both of these main communication networks, they've gone beyond just transmitting voice and video. Uh, they carry data as well today and other high traffic uh, information or service needs. But these are mostly the key bedrocks that you'd have within a computer network setup. Okay, so maybe the next question we should be asking ourselves is what really distinguishes a computer network? if we understand that computer network is just a set of serial lines that have been used to attach terminals. Terminals here are various devices, computer devices that you might find, or network system that you might find. Uh, and the mainframe here just also revolves around key server systems that are used to address various high uh, capacity and performance needs like servers and routers and switches and whatnot, or gateway devices have. So yeah, what really distinguishes computer network? Uh, well, first thing is its generality. It's in terms of uh, the purpose for which it was designed. If you think about it today, computer networks have addressed a number of key things, have made life a lot more easier, a little bit more comfortable, uh, able to access resources at the fingertips at any given point in time uh, that we need. And, uh, and, and the systems have become really much more accessible. A lot of computer systems these days are very accessible. You notice that we have smartphones across board. It's every country that you go to today has some kind of smart device that they use within their country, or it's used by even the youth or businesses or what have you. Okay, so its generality alone, it's one key distinction. Another one would be probably the fact that it's built on general purpose programmable hardware. Most of the instructions are based on programs that are written by somebody in some kind of language and embedded into some of these devices to make processing of information back and forth a lot easier for you and I, basically. So one other key distinction is the fact that they built on general purpose programmable hardware. Okay, and the key, I know one word we should probably keep note of uh, within this is the purpose. Okay, most computer systems are built for specific purpose. Yeah, as you notice, obviously your cell phone can do so much, but it can't really address a number of other things because it has a specific purpose it was built for. If you take a device like a router, it's mostly built for routing packets. Switch for switching packets. That's the kind of purpose it was programmed for. So you can't be asking to do anything other than that. Okay, but that's what forms some of its uniqueness or distinctions. And then you also have it supports a wide range. Computer network support a wide range of applications that you might have. I always use a cell phone as a typical example, a smartphone as a typical example, because today you can do a variety of stuff on your smart devices, wherever you find yourself. As long as even without connectivity, you can still do a lot of stuff on your handsets, on your mobile devices, or your smart gadgets. Very good. So one other distinction is the fact that it's able to support wide range of application, kind of like what a computer would do. A computer was designed basically to address or support a wide range of application to make business processes or other kind of services much more accessible, much more uh, what would be the word to use here? Uh, Effectively, efficiently, you know. So, anyways, those are some of the key distinctions that you'd see within most computer networks. Generality, built from general purpose programmable hardwares for specific purposes. and support for a variety of applications. Great. Now let's try to look at, let's break some of these words down, like information, words like information, computer, and network. Let's try to break it down. Information obviously rides on a computer, sorry, usually formed within a computer, and it rides on a network, right? So let's try to look at some of these three key words of information, computers, and networks. So at least we get a bit of understanding of these three words and how they play into computer networks or data communication in general. Information is obviously anything that is represented in either form or substance, or as a substance. Form as in it's been having a bit form or can be spliced up into bits. Okay, that the computer can easily interpret. Okay, since computer systems usually deal with bits and bytes, or in a way it deals with uh, signals at either a binary or analog level, sorry, a digital or analog level. Okay, so information can be represented in a form, can be represented in a form or as a substance. Usually as a substance, it cannot be represented as a bit. And a typical example will probably be your audio or voice transmission or video transmission. Those are usually hard to represent as bits. So they will usually have more of a signal as its representation, whereas form is where you can actually uh, kind of like splice it up, for lack of a better word, or you can use electromagnetic pulses to build them up to form a given sequence for a given type of information, either a word or a whole sentence or what have you. Okay, we'll dive into some of these things later on, so we understand how bits and bytes or binaries and digital information or analog information fit into these two. But forms will fall more or less under digital information, whereas substance will fit more into the analog information. So obviously you can represent those in the bits. Properties, they're infinitely replicable. You can replicate them in any form or shape that you want. Yeah, informations can always be replicated in different forms. So at least to able to bring simplicity or understandability to the end user. And computers are usually used to obviously manipulate information, whereas network creates the access to those information. So like I was putting earlier on, information, computer, and network, you have information being put together or formed, or in this case manipulated by a computer system, and then network provide that infrastructure for it to ride off in terms of transmission, especially when you want to forward information or relay the information from one node to another node. Okay, networks. When it comes to networks, from these three key words over here, the potential uh, for networking, the potentials are to design networks or to build networking systems. And in terms of that, when it comes to network, we're looking at how bits are moved uh, everywhere, but very cheaply with a desired performance characteristics. So one of the potentials that a network would have is uh, creating networking, okay, or creating the framework or platform for bits to be moved across, either uh, with cheaply or at a cheap cost or at a least cost. Is a term that's used at a least cost with the desired performance that everybody can appreciate or that a system can appreciate. And network also do creates provides connectivity. Connectivity is in general terms what you would expect within most computer networks. Okay, and network delivers that key part of that connectivity. So if you really want to have connectivity, then you definitely do need a network in place. Which, in other words, what that really means. Uh, Now, what is really what in much more simplified terms, what is connectivity? Because we over here we're saying that you need a network to provide you with that connectivity. But what really is connectivity? Okay, connectivity can either be a direct, where you connect nodes physically, can be a direct link via those sets of uh, serial links either directly, so you have a physical medium that connects nodes together. You can either have that in a direct form or an indirect form, where you wouldn't necessarily have to go to a physical medium directly connected to another node to have information or transmission possible or to create that network. But you could have it in such a way that the devices can use other means of accessing uh, uh, a particular node without necessarily connecting directly to it. So when we talk about direct and indirect in terms of connectivity, we're looking at how a physical medium or that set of serial link is established between two nodes to form the network. Okay, so I said it can be either direct, where you have actual physical connectivity between nodes, or indirect, where there's not a physical medium within transmission, but you could go through other nodes just to form that networks. So through other access nodes, which are known physically, to provide the access to other nodes within a given network. Okay. Uh, let me use a typical, simple example. For instance, assuming you want to get two PCs or two laptops, and you want to just maybe transfer files across it. Maybe you have some video files or documents or whatever it is, multimedia content that you want to exchange, or even a resource, maybe a web page on a given one laptop that you want another laptop to access, without necessarily getting some of the key network devices that can help you create that connectivity. You can just link up a cable and a cable to the two PCs among or between the two PCs, and you create what you call a direct network, okay, or a direct connectivity to form a network. All right, and then the indirect way is when you have maybe accessing resources that are on a different uh, side of the network. So you don't necessarily have like a physical cable connecting the two systems that want to access the information or that wants to transmit information, but you could pass through other nodes just to get that particular device. And that's what even the internet is all about, really. Because information that you're accessing today on your devices are probably stored or at a particular place that your physical devices are not like connected to directly, but instead be connected via other nodes, which could be routers, switches, uh, access points, via either radio services, technologies like 4Gs, 5Gs, or what have you. Okay, and those are considered indirect approach of connectivity. Connectivity is also the magic that's needed. Well, basically, it is the magic that's needed to establish connectivity or to establish communication. If if you do not even have a direct point-to-point physical link. Okay, so that's where you try to really get what connectivity is really all about. It's not necessarily about having that direct medium of connectivity, but it can also be indirect, you know. And what is established is the magic of what connectivity to enable uh, the need for communication to take place. Okay, and a trade-off with, especially when you don't have a physical link to interconnect various nodes for transmission purposes, you'd have a performance uh, being in a way the giveaway. It has to give in because once you do create links or networks that do not have physical links involved, you you're going to realize that performance seems to suffer. Or in its worst case, you say they're characterized by worst uh, as a trade-off. Okay, at worst as a trade-off, the performance is suffers or takes a plunge in that aspect, especially when you have the physical link involved. Okay, and then the moving on, the some of the building blocks that forms or that enables connectivity uh, would probably be the various devices that are interconnected. Your nodes, general terms. So we have your PCs, your special purpose hardware, which could be a switch, router, access point servers, your cell phones, and many other devices. Those are would be considered nodes of some of the building or as one of the building blocks of connectivity. Yes, so you do have a host, switches, hosts will be PCs, workstation terminals, and what have you, servers, and switches and routers, access points. I usually say the networks nodes falls within this part, or these switches, routers, access points. Those will form your network devices, whereas your host devices are your PCs, your servers, your terminals, basically, workstations, special purpose hardware, your cell phones, smart devices, and other smart gadgets that you might have. Those who form the host or your terminals or workstations involved. But they're all categorized as what? Nodes. But when we want to like get a bit technical, we try to group PCs, special purpose hardware, servers, what have you, as host devices, and then the device that facilitates the transmission or makes the connectivity possible. We factor them under network devices, which will be a switch, which will be in this case will be a switches, the routers, what have you. Now the actual link uh, that makes the connectivity possible is your physical infrastructures or your wireless infrastructures. With over here with the links, then when it comes to wired transmission or wired links, we're looking at coaxial cable. Coaxial cables are uh, the type of cable that you use for your TV station from your antennas. Those you have a single copper wire within the cable, and that helps you either receive video feeds for your DSTVs or direct TVs. Basically, a cable TV services uh, uses coaxial cable, and then fiber optics also does the same thing, but on the uh, As a cable, it has a different property as compared to the coaxial cable. Coaxial cable and twisted pairs are purely copper based, whereas fiber optics uh, are glass or plastic based in terms of material composition. Okay, but they are all just cables in general that forms the links needed to connect or create connectivity within nodes of a given network or between nodes of a given network. And links can either be created as point to point where you have two nodes physically connected via specific cable medium or even a wireless medium. Okay. Now we need to keep in mind that links can either come in physical form or a wireless form or non-physical form. What I mean by non-physical is when you use the airwaves uh, to transmit or to create that connectivity, which a lot of you already uh, do experience today with your mobile devices, where you actually uh, use your antennas as a transmitting as a signal transmitter to access cellular network base units to create connectivity to a given network so you can actually make calls or access internet resources wherever you find yourself. Links can also create multiple access where a medium can be shared by multiple nodes. Okay, great. Now usually when we talk about links and how they create connectivity, especially at this link at the point-to-point or multi-point access level, one question also comes up is why don't we just connect like these, for instance? Why don't we just connect two devices every single time, or a device to another device just to create connectivity? Why don't we just do that? Because if you delve down or if you don't know by now, uh, uh, networks today or connectivity today are not established like this anymore. They are a lot more in indirect forms where they incorporate various other network devices or nodes to create better accessibility to information from different places. Okay, so the question is, why don't we just connect each node with every other node just to create connectivity? Well, the first issue you're going to have is limitation because assuming you were to connect two nodes with given link, you're going to have issues with how the link shares information because you have a number of other nodes that are using the same link. So your issues that relates to performances and what have you, or congestions and uh, packet losses are bound to happen, are bound to take place. So one key reason why you don't want to just connect nodes to every other node is to uh, avoid limitations. Uh, and there are ways to picture it that can really give you a clearer picture of why it's just not a realistic approach to form connectivity. Okay, I can give you a scenario as in let's say you had three devices uh, that are interconnected, like as in this way, in the sense of connecting each node to